This video is for the Unit 7 right triangle exam review. Questions 3A, 3B, and then 3C through 3F, all dealing with right triangle trig. Starting off, right triangle trig ratios can be defined as the following. Based on angle theta, we can label our side lengths as the hypotenuse, the adjacent, and the opposite side. The hypotenuse, the adjacent, and the opposite side. We define the trig function sine, the sine of some angle theta, as the opposite over the hypotenuse, the opposite side over the hypotenuse. We define the cosine ratio as the adjacent side over the hypotenuse. And lastly, the tangent ratio as the opposite over the adjacent. So, from a very basic standpoint, if I give you a right triangle and we know all three sides, we can set up a ratio. Even if we don't know all three sides, we can. But here, I'm asking you for the sine of angle x. So for the first row of questions, I'm using x as my reference angle. I'm going to label my sides accordingly. This is going to be my hypotenuse. It's the biggest side in the triangle. The adjacent side is the other side that's in my highlight, that makes up my highlighted angle. So this is my adjacent side. And lastly, this would be my opposite side. So if I wanted the sine ratio, the sine is the opposite over the hypotenuse. The opposite side, 12 over the hypotenuse of 15. This reduces down. If it does, we do it, giving us 5 in the denominator and 4 in my numerator, 4 over 5. Same idea for the cosine and tangent. We're going to make ratios. The cosine of x is the ratio of the adjacent side, 9, to the hypotenuse of 15. This does reduce down to 3 over 5. Tangent ratio is going to be the opposite side of 12 over the adjacent side of 9. This also reduces down to a value of 4 over 3. Okay. Now, when I switch my angle of reference, in this case, we're going to do now the sine of z, cosine of z, and tangent of angle z. I'm going to go ahead and change my reference here, which means that my side ratios are, how I label my sides are also going to change. From angle z, this is the hypotenuse, same as the previous. This is now my adjacent. 12 now becomes the adjacent side, and 9 becomes my opposite side from angle z. So when I want the sine, cosine, and tangent, we're going to take the opposite side of 9 and divide it by the hypotenuse of 15. This reduces down to 3 over 5. Cosine ratio is the adjacent side of 12 to the hypotenuse of 15. 12 over 15. This reduces down to 4 over 5. We reduce if we can. And lastly, the tangent ratio is going to be the opposite of 9 over the adjacent of 12. This reduces down to 3 over 4 as my answer. So trig ratios are all about what our reference angle is and labeling my sides accordingly. It changes depending on what reference angle we are looking at. Okay, now, how does this actually apply to solving for x? So here's where I know all the sides. I'm just asking for the ratio. We can use trig to help us solve for x, whether x is an angle measure or whether x is a side length. So we're going to start off with 3C. I'm going to solve for x in this particular case. I'm given my triangle. My angle of reference here is 41 degrees. So I'm going to go ahead and label my sides accordingly. This is the hypotenuse. The other side length that makes the angle is the adjacent, and that makes this the opposite side. This lets me know that I'm using the trig ratio of, well, I want to know, given the opposite and the hypotenuse, this is in fact the sine of theta ratio. Now, it's important to note that if I'm looking ahead to 3D versus 3C, I'm looking for a side length in question 3C versus in question 3D, I'm actually looking for an angle measure. So I know in 3C that I'm going to use regular trig or and define the trig ratio here versus 3D where I'm going to use the idea of inverse trig to help me solve. If you don't recognize this ahead of time, that's completely fine. We're going to approach the problem exactly the same way. But just for those savvy problem solvers, I'm looking for a side length here, so I'm going to use the trig ratio. Here I'm looking for an angle measure, so that means I'm probably going to use inverse trig at some point to help me out. Okay, so not getting too far ahead, let's go back to 3C. We're going to plug in our relevant information. I know what the angle measure is, so 41 degrees. That is the sine of 41 degrees is equal to the ratio of the opposite side, which is x, over the hypotenuse, which is 26. This looks kind of clunky. However, if we remember, all we need to do is put this over 1, and now we've created a proportion that we can cross multiply and solve. X times 1 gives me x, and this is going to be equal to 26 times the sine of 41 degrees. X is by itself here, so if x is by itself, that means my answer is just 26 times the sine of 41 degrees. I can type this into my calculator, and we get an answer of 17.1. One thing to note on the calculator, we must be in mode of degrees. Mode of degrees. It makes sense that we're in degrees because we have a degree measure in our triangle. The other angle measure in the calculator is radians. You don't know what that is yet. It'll mess you up if you plug it in. You'll get a weird answer. Make sure your mode's in degrees. Okay, 3D. Again, I have an angle of reference. X this time. I'm still going to go ahead and label my triangle. This is the hypotenuse. The other side length that makes up the angle is going to be my adjacent, and the other side is going to be the opposite. I'm given the adjacent side and the hypotenuse in this particular problem, so that lets me know that I'm using the cosine ratio. Cosine is the adjacent over the hypotenuse. Now, I'm going to plug in my relevant information. Cosine of x degrees is equal to 43 over 47. I have to get rid of the cosine. X isn't by itself. So we talked about this. We're going to actually have to use inverse trig here to help us solve. So to get rid of the cosine, I will take the inverse cosine of both sides. Inverse cosine of both sides undoes the cosine, leaving us with x degrees is equal to the inverse cosine of 43 over 47, which equals 23.81 degrees. 28.31 degrees. Now in class I had showed some of you, if you're being a little bit savvy with our problem solving, if we recognize that x is in fact a degree measure, we can jump straight to x degrees is equal to the inverse cosine of 43 over 47. Essentially next to last step of our equation, and we still end up with the same answer if we recognize x degrees is equal to. 3E, last problem. Once again, we'll go ahead. 32 degrees is our angle of reference, which means that this is my hypotenuse. This side, which makes up the angle, is the adjacent, and then the opposite side is our leftover. Looking at what ratio deals with, again, the adjacent and the hypotenuse, we actually get the cosine of theta is equal to the adjacent over the hypotenuse. In this case, when I fill in my information, I know that the cosine of 32 degrees is equal to the hypotenuse of x and the adjacent of 24. In order to solve this, we make it into a proportion by putting it over 1 and cross multiply. 1 times 24 is 24. X times the cosine of 32 is x cosine 32. In order to get the x by itself here, which it is not already by itself, so we're going to have to go ahead and divide both sides by the cosine of 32 degrees. Cosine 32 degrees. These undo each other, giving us x is equal to 24 over the divided by cosine of 32, which is 28.3. These first three examples are a great representation of sometimes we're solving for a side length, as in 3C and 3E, and sometimes we're finding for the angle measure. If we're looking for an angle measure, we're using inverse trig. Very quickly, for the last three examples, I'm going to go through these rather fast due to the fact that this video is running a little bit longer. So 3F, 3G, and 3H, I'm going to label all my sides right now based on my angle X, angle given 27, and angle given X. From a purely problem-solving standpoint, I'm going to be using 3F and 3H due to the fact that I'm looking for an angle measure. 3G, I'll have to set up the proportion and solve. So, labeling my side length, hypotenuse, adjacent, and opposite. hypotenuse, adjacent, and opposite. Hypotenuse, adjacent, and finally the opposite side. 3F, since I'm looking for an inverse trig, I know that x degrees is equal to the inverse trig function. I'm given the opposite of the hypotenuse in this case. No, I'm given the opposite of the adjacent, I'm sorry. So I will use, in fact, the inverse tangent function. So the opposite side being 4 and the adjacent side being 9. This gives me 23.96 degrees. Going the quick way using inverse tangent. We'll jump over to 3H. Once again, we are looking for x degrees. We're given the opposite and the hypotenuse in this case. So that means we're going to use the inverse sign of 16 over 20, where x degrees is equal to 58.21 degrees from our calculator. For 3G, we are given the angle measure of 27, and we're also given the opposite and the adjacent, meaning we're using the tangent ratio of 27 is equal to the opposite x over the adjacent 29. We put this over 1, cross multiply, giving us x. 29 times the tangent of 27 degrees, which gives us a value of x is equal to 14.8. There'll be more of these problems on the next page of the video. I'm going to go ahead and not actually do those. These are a great example. They're more of the same using trig and inverse trig to help us solve. Perfect. Expect lots of these on the test.